Have you ever wondered what if artificial intelligence could actually think and adapt like a living brain? Could machines one day sense patterns, evolve on their own, and make split-second choices, without a single line of code telling them what to do? Is this the next leap in AI or just a wild dream? And what if I told you, this future is already unfolding? What happens when we build machines inspired by the brain's mysterious wiring? Machines that don't just crunch numbers, but actually learn and adapt in real time. Could they surprise us? Maybe even outsmart us? Imagine a world where robots don't just follow orders. They evolve, make choices, and maybe even develop instincts. Is that world closer than we think? Are we on the edge of a new era, one powered by neuromorphic engineering and computing? In this video, we'll dive into the secrets of neuromorphic computing, uncover how it's rewriting the rules of AI, and reveal the jaw-dropping moments when these machines did the unexpected. Are you ready to question everything you know about intelligence? Let's find out together. Neuromorphic computing is a field of technology that aims to design computer systems inspired by the structure and function of the human brain. Traditional artificial intelligence relies on fixed algorithms and requires significant computational resources to operate. In contrast, neuromorphic systems are modeled after the human brain's method of processing information. These systems utilize spiking neural networks, which replicate the way biological neurons communicate through electrical impulses. As a result, neuromorphic computing enables artificial intelligence to be more adaptive, energy efficient, and capable of learning in real time. Although neuromorphic computing is still in its developmental phase, it is attracting significant attention from both major technology companies and research institutions. These organizations are investing in research to advance the capabilities of neuromorphic systems. The primary objective is to develop computer chips that not only process information but also emulate the brain's efficiency by using networks of artificial neurons and synapses. Notable examples of neuromorphic chips include IBM's TrueNorth, Intel's Loihi, and SpiNNaker from the University of Manchester. These chips represent important advancements in building machines that can learn, adapt, and process information in ways similar to the human brain. Neuromorphic chips are capable of complex tasks, including real-time pattern recognition, learning from new data, and making autonomous decisions. Their architecture supports parallel information processing, which is similar to the way biological neural networks function. This design allows them to excel at sensory processing, such as analyzing visual and auditory data, much like the human brain. Neuromorphic technology has the potential to transform fields such as robotics, artificial intelligence, and healthcare by enabling machines to better understand and interact with their environment. Here's something that might blow your mind. The human brain processes 1 million times more information per joule of energy than today's supercomputers. Think about that. Your brain is way more energy efficient than even the most advanced AI systems. Neuromorphic chips aim to bridge this gap by replicating the way neurons communicate, making AI smarter and more power efficient. But what does this mean for the real world? Neuromorphic AI could revolutionize everything from healthcare and robotics to smart cities and personal devices. Imagine machines that can learn, adapt, and make decisions almost as efficiently as we do, all while using a fraction of the energy. That's why this technology isn't just an upgrade. It's a game changer for the future of thinking machines. We have seen the capabilities of neuromorphic AI. Now, a critical question arises: what are the consequences when these systems begin to make decisions independently? This is a turning point that demands our attention. Consider a machine that does not simply execute commands but evaluates choices, adapts from errors, and acts in ways its creators did not anticipate. This is both the potential and the profound risk of neuromorphic AI. Next, we will examine the first documented instances where these systems made unexpected decisions. The implications are significant. Let us proceed. So what can neuromorphic computing actually do? Well, here are some mind-blowing applications. 1. Autonomous robots that can learn and make decisions on the fly. 2. AI-powered medical diagnostics that adapt and improve over time. 3. Super efficient brain-computer interfaces that could redefine human-machine interaction. 4. Self-learning cybersecurity systems that detect and neutralize threats in real time. In 2021, Intel's Loihi chip was tested in a robotic arm tasked with sorting irregularly shaped objects. Engineers noticed something strange. It began adapting its grip and positioning without being explicitly reprogrammed. It learned through repeated exposure, mimicking human motor learning. The researchers called it a glimpse into machine intuition. At the University of Manchester, the SpiNNaker chip was tasked with controlling a simulated rat navigating a maze. Within hours, the AI began to develop a shortcut, not the shortest path, but the path of least resistance. It made decisions that resembled instinctive behavior, even correcting previous failed paths. IBM's TrueNorth chip was embedded in a visual recognition system. It was exposed to partially obscured images like a child's drawing of a stop sign. What happened? It accurately identified the sign, but not by analyzing the shape. It correlated contextual features around the image, just like a human brain compensating for gaps in vision. These are not just cool tricks. These are early signs that machines are crossing a threshold, from program tools to adaptive entities capable of behavior no one fully predicted. With neuromorphic AI advancing so rapidly, it's natural to wonder, what could it truly mean to create machines that think, learn, and evolve like we do? Could we be on the verge of something extraordinary? Or are we opening doors we don't fully understand? Some scientists and ethicists raise fascinating questions. Could neuromorphic AI become so complex that it surprises even its creators? What if these machines start making decisions on their own in ways we never anticipated? How might our world change if their goals drift away from ours, or if they develop unexpected behaviors? Yet, others are captivated by the possibilities. What if this is the next leap in intelligence, a future where machines don't just follow instructions, but actually reason, imagine, and maybe even create? Could these advances help us solve mysteries and challenges we haven't even dreamed of yet? The conversation is alive with curiosity and debate. Some see boundless promise, while others urge us to pause and reflect. The ethical puzzles are intricate, and the answers are far from simple. What questions do you have about this future? What excites you? And what makes you pause? Share your thoughts in the comments. Let's wonder together about where neuromorphic AI might take us. If this video made you think differently about the future of AI, then hit that like button and subscribe to The Curious Explorer. Your support helps us keep bringing you the most fascinating stories and breakthroughs from the world of artificial intelligence. Every like and subscription tell us you want to see more content that challenges the way we think about technology and its impact on our lives. And hey, if you found this video thought-provoking, share it with a friend or colleague who's curious about where AI is really heading. The more we talk about these changes, the better prepared we'll all be for the future. Sharing knowledge is how we grow as a community, and your voice matters in this conversation because the future isn't coming, it's already here. We're living in a world where AI is becoming part of our daily routines, from smart assistants to self-driving cars, and the pace of change is only accelerating. Staying informed is the best way to stay ahead. So hit subscribe and stay curious. Join us on this journey into the unknown, and let's explore the future together, one discovery at a time.